So here is example B, and we want to list all the possible rational roots of this polynomial function, negative 3x cubed minus 5x squared plus 21. And we're not trying to solve, we're just practicing using the rational root theorem. And so try this out, see if you remember how to do this problem. So it's going to be the P over Q, or I call it back over front. Back is the constant, the front is the leading coefficient. So pause the video and try this out. So the back number is 21. The leading coefficient is 3. Now the sign doesn't matter because if you remember, you always have to list plus or minus. So let's just list our factors of 21 first of all. So that's 1 times 21 and 3 times 7. And then the denominator, that's 1 times 3. So let's list them all, starting with 1 in the numerator. So that's going to be 1 over 1 and 1 over 3. So plus or minus 1 over the denominator 1, and then plus or minus 1 again over the denominator of 3. Then we repeat with the 3, and we continue with the same process. Plus or minus 3 over 1, plus or minus 3 over 3, plus or minus 7 over 1, plus or minus 7 over 3. Then last, we have plus or minus 21 over 1 and plus or minus 21 over 3. Now this is the case where we have some duplicates, right? We wouldn't want to test more numbers than we needed to in this case. And so what we want to do is reduce when possible. So 1 over 3, that's fine. 3 over 1 is fine. Oh, 3 over 3 is 1, and so we'll want to take out that duplicate, right? 3 over 3 is 1, and 1 is already represented. Then the next one is 21 over 3, because 21 over 3 is just 7, so we don't need to list that again. So that's practice in just listing your possible rational roots. So let's try one more example of listing the rational roots and then solving. So find all the real solutions of x cubed minus 5x squared minus 2x plus 24. Again, it's not factorable using factoring by grouping, and so let's use a rational root theorem. So let's use or list our possible rational roots, which is 24 over 1. So really we're just looking at factors of 21. So let's start with plus or minus 1, plus or minus 24, plus or minus 2 times plus or minus 12, right? 2 times 12 is 24. Plus or minus 3, 3 goes on 24, 8 times, so 3 times 8. Plus or minus 4 times 6 is 24, and we are done. So now you get to choose any number that you would like. So if you wanted to, you could choose 6, you could choose 8, you could choose 12, you could choose negative 3, and so forth, right? It's a matter of choice. You choose whatever number you feel would work. Again, I would not choose like 5 because 5 is not a factor, right? I did not list that. It's not a factor of 24. I wouldn't try 7. 7 doesn't go into 24, so it would never work. So let's try out. Let's see. I want to try 1. Okay, so let's try 1. Again, if I list 1, that's x minus 1. And so then I list my coefficients. I need to do synthetic division. 1, negative 5, negative 2, and 24. So if I try this, 1 times 1 is 1. 1 times 1 is 1. This is negative 4. 1 times negative 4 is negative 4. Negative 2 minus 4 is negative 6. Negative 6 times 1 is just negative 6, and so that doesn't work, right? That doesn't go in perfectly. So let's try, let me try a larger number. Let's try negative 2. So again, I'm just picking numbers. Not really, there's no like magic to it or anything like that, unfortunately. You just have to try some values out. And then hoping after that point, I can factor it further. So let's do negative 2, x equals negative 2, meaning the factor form is x plus 2. So 1, negative 5, negative 2, and 24. So doing synthetic division again, I'm trying to get a remainder of 0. So negative 2 times 1 is negative 2. Negative 5 minus 2 is negative 7. Negative 7 times negative 2 is positive 14. 14 minus 2 is 12. 12 times negative 2 is negative 24, and that goes in perfectly. So that does give me a remainder of 0. This is x to the 0, x to the first, and x squared. So let's write this, our factor of x plus 2, and write our result from the synthetic division. So that is x plus 2 times x squared minus 7x plus 12 equals 0. And let's factor the 12, the trinomial here. So it multiplies to 12, that adds to negative 7, and that is negative 4 times negative 3. And so we have x plus 2 times x minus 4 times x minus 3 equals 0. Then using the zero product property, x will equal negative 2, x equals a positive 4, and x equals a positive 3. So those are all of our x-intercepts. Now again, let's look at our y-intercept just to kind of start pulling all of this together. Our y-intercept is when x is 0, so go to the beginning, the original function here. Shouldn't be a 0 there. And so that would be 0, x is 0, y is 24. Now, if we were to graph it, just to graph one all the way, so we start from the beginning and graph it. Let's put our x-intercepts at negative 2, 4, and 3. Negative 2, or 3 and 4. Our y-intercept is a positive 24, so again, just a sketch. Now, let's look at the end behavior of the graph. It's x cubed. X cubed means the degree is odd, and the leading coefficient, the sign, is positive. So that tells me that my ends are going up, or going opposite direction, so up on one side, down on the other side. And because it's positive, I think about more of a positive slope, so up on the right, down on the left. And then let's draw our graph connecting them. And so that's just a sketch, right? More so we're looking at the x-intercepts, we're looking at the end behavior, we're looking at the y-intercept. Where the turning points are, we don't know how to find those yet, but this is a good general sketch of the graph.